Those red calculators back there. And then hold up your calculators. Anybody else have a calculator? Oh, there's a bunch of them missing now. Does anybody have a calculator like, hold up that one? Does anybody else have a calculator like that one? And then all of yours, do they print across the screen?
Yes.
That's what you're looking for. All right? Gentry's, that one doesn't, so it makes it a little more difficult. Gentry, I'll try to explain both ways as we go through this, all right? Go ahead and click on it. Do this for me. Push the little indented button. Point towards the board. Get closer. Go to pointer options. Pin. Now, every time you're going to have to push that little button to switch slides. So push the little button and switch slide. It'll say next and just go to next. On your calculators, everybody looking at their calculators, find these three buttons. And what I want you to do is circle them for me up here. It's real hard to see. Do it on the big calculator. You see the SIN, the COS, and the TAN buttons right above the parentheses? Circle those three. Find those three buttons on your calculator.
Found them.
Does everybody see them on their calculator?
Yep.
Those are the buttons that we're going to be using. Those are trig ratios. What trig ratios are? We've been dealing with setting up proportions. And somebody a long time ago said, hey, why make Fletcher set up a proportion when every single time, if it's a 30, 60, 90 triangle, or a 45, 45, 90, or a 50, 40, 90 triangle, any kind of right triangle, that the ratio of these sides are going to be the same. So what they've done is they went through and figured out all those ratios for you. So now, instead of having to set up a proportion where you got a fraction on this side equals a fraction on this side, we're just going to have to do one side. The other side's already set for us. It's here. Or in your calculator. Alright, so everybody found those buttons, right? First thing I want you to do, just to make sure everybody's is on the right thing. Take your calculator and do sine, hit the SIN button. Sorry, I gotta make sure I'm helping Maya out here. And then type in, I don't know, give me an angle. 63 degrees. So sine 63 degrees, hit equals. What does your calculator say? Does everybody's calculator say that?
Yes.
You said 0.8, right?
0.891, so on and so on. Everybody says that. You got to make sure. You got to make sure that your calculator says the same thing ours does. Otherwise, it's in the wrong mode, and we got to figure that out, and it's going to give you the wrong answers.
It's not written on Gentry's. It's just giving him 63 again.
Let me see. Oh, that's because on these calculators, Gentry, so on this one, what you'll have to do, put in the angle, and then hit the sine button.
Oh, okay.
So it's like backwards. That's why I want you to use the red one, so that I don't have to explain it two different ways. But it's sort of backwards on that one. Does everybody understand all that so far?
Yep.
Go ahead and go to the next slide. So these trig ratios, again, all it is we're going to be able to solve for parts in a right triangle. You'll have to fill in stuff on your notes as we go here. This part, I don't think there is anything to fill in. So we're going to be finding parts of right triangles. We're going to be finding parts of right triangles and solving problems using those. If you're solving problems out in the real world, this is probably what you're using. It's some kind of trig. All right, go ahead, next. On this one, First thing we gotta do, we gotta pick an angle. We're gonna pick angle A. You cannot pick the right angle. Does everybody understand that? It's gotta be one of the other two angles. The other two angles are acute angles, it's gotta be one of those. So put the little arc in the right angle. Go ahead and click the board or go to next and it'll put that little arc in angle A. We're gonna pick angle A. When we pick that, then we gotta label it, and we're gonna label it this same way every time. Last time we were labeling it like L, and L times the square root of 2, L, 2L, and L times the square root of 3, all that. We're gonna label it a different way this time if we're using trig stuff. This trig stuff will work for all the 45, 45, 90, and 30, 60, 90. So if you never ever wanted to use the 45, 45, 90 again, Joseph said he didn't understand it, he doesn't want to use it, use the trig stuff. Alright? So click the board, draw what this shows you. The side across from the angle that you picked, go ahead and click it again, is called the opposite leg. That's what you're going to label it every time. Now, do I expect you to write out opposite every time? Probably not. Alright, something like that. As long as you can understand what it is, that's fine. Click it again. The other leg is called the adjacent leg. What's adjacent mean again? Neighbor, hooked to. So the one that's hooked to the angle that we picked, does everybody see how that leg's hooked to angle A? That's the adjacent leg. So you got your opposite leg and you got your adjacent leg. The side across from the right angle is always called the what? The hypotenuse. Click it again. Right. If I spell something wrong on your paper here, I'm sorry. No making fun of it. Every single time we're going to label every right triangle that way. A little easier than the L and all that stuff, isn't it? Somebody a long time ago, some math person came up with this saying to try to help you remember the sine, the cosine, and tangent and the way that they're related and the way that they're set up. And it's SOHCAHTOA. Alright? SOHCAHTOA. And at some point I'll probably write this on the side of the board over here, SOHCAHTOA, so that you can look up there and see it and try to remember it. You're going to click the board. The S stands for sine. On your calculator, that's that SIN button. Sine. Alright? The sine is always, go ahead and click the board, the opposite leg over, anybody, stop. Anybody have a guess what H stands for? Over hypotenuse. Opposite leg over hypotenuse. The C part. The C stands for cosine. Cosine. That's another trig ratio. The three trig ratios we're going to deal with: sine, cosine, and tangent. Those are the three we're going to deal with. There's others, but we're not going to deal with them in here. Anybody have a guess what the A stands for?
Adjacent.
Adjacent leg. Anybody have a guess what the H stands for? So the cosine, go ahead. The cosine is the adjacent leg over the hypotenuse. You put the number that matches up for the adjacent leg over top of the hypotenuse as a fraction. The last three. Anybody guess what T stands for? Tangent. And then what's the O stand for? Opposite leg. And over the adjacent leg. So SOHCAHTOA, just the same to help you remember it. All right, so sine opposite over hypotenuse. Cosine, adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. Flip over to the next one. Skip that one. Just heard some teacher got fired for having that. It was inappropriate, I guess, to have a Native American thing on there, so.
They're just soft.
So we're skipping over that. Forget it's on there. I forgot to take it off. Fill this in. This is the actual fractions. If that confused Fletcher looking at it this way, the way that we just did it, this is the mathematical way. So we're going to set up an equation, and it's going to say the sine of angle A equals the opposite leg, whatever the opposite leg is, over the hypotenuse.
Question.
Yep.
The tangent, I thought it was supposed to be over adjacent.
Oh, it is. Mark that out. Dang, how'd I do that? Put adjacent leg. Jeez, nice. It's like it's my first year or something. Maybe it's because it's getting close to my last year and I'm getting senile. Adjacent leg, yeah.
You can't retire on the SEAC or something.
Feel like I need to when I make mistakes like that. The key to all of this is those three equations right there. Every time you're going to say the sine of some angle equals something over something. And we're going to set that up. That's our proportions that we're setting up. Notice that there's only one fraction this time because on the other side is the sine, cosine, or tangent of one of the angles. And the calculator is going to tell us that. All right, flip to the next slide. Oh, hold on. Everybody got that? Does that make sense so far? I mean, I know we're rushing through this, but I'll show you as we go. Next thing, to find the sine, cosine, or tangent of an angle, there's nothing to fill in on this because we're going to do some stuff together. To find the sine, the cosine, or tangent of an angle, you pick the angle that you want to deal with. Again, which angle are you not going to pick?
Right.
The right angle. Don't pick it. Label the triangle, opposite, adjacent, and hypotenuse. Then you write the ratio, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, whatever it is. That'll be your sine, cosine, or tangent, whichever one you're on. Now, the thing I want you to do, on the packet that you picked up from up there, turn to the third page at the very top. All these packets, we are going to turn them in. They'll be done before we leave today. So we're going to do them all together right here, and you're going to turn it in.
Yippee.
Go ahead and go to the next slide.
This page right here.
Yep. So you should see problem 46. It looks like this. What I want Maya to do for me, we're going to pick angle A first. So put the little arc in angle A. Do the same thing on your paper. And we're going to label it. The side that's 55, draw an arrow towards the 55 for me from that angle. That's all right. Everybody understand that? What's that side get labeled? That's the opposite leg. So put opposite over there. OPP or whatever. The 48, that's the other leg. What's it get labeled? Adjacent. And if you want to abbreviate that, you can. That's fine. Whatever makes sense to you. So write ADJ or ADJ or something over there. Remember all those times you laughed at me, Mike, because it did that to me? All right.
I love it too.
Put OPP up on the top.
You guys are all in such blunt moods.
I'm actually in a really good mood.
And then the side across from the right angle, draw an arrow from the right angle towards that other side. What's that side get labeled? Hypotenuse. And you can abbreviate that if you want. Now all we're going to do to find the sine, the cosine, and the tangent is do what SOHCAHTOA tells us. In the SOHCAHTOA, the sine, is what over what?
Sine over
What two parts for so?
adjacent.
The S is sine, O stands for what? Opposite over hypotenuse. So you're gonna write a fraction. So in that first blank there, put a fraction mark. And you want the opposite. How long is the opposite? 55. That goes on top. And how long is the hypotenuse? 73. So write 55 over 73 in that first blank right there. Does everybody understand hers, even though it's, the pen's going crazy on her? 55 over 73. Does everybody understand that? That's the sine of angle A. It's that simple. Cosine. What two parts was the cosine?
Adjacent over hypotenuse.
What is the adjacent this time?
That's
48. What's the hypotenuse? 73. So 48 over 73 on that next line.
Is that
Cake,
right?
dude.
Is that the answer for that? Or is
That's
that-
all we want this time, yeah. Now, we're leading to, we're gonna use this stuff, but we're leading to that, all right? And then the tangent. Which two did the tangent, the toe apart deal with?
Opposite leg over 40.
Opposite over adjacent, right? So 55 over 48. Does everybody understand it so far?
Yeah.
What's gonna change? Now, everybody's got that much?
Yeah.
Click your button, erase everything on the screen. So go to pointer options, erase all. We're gonna go over to angle B. What changes when we move to angle B? We're dealing with a different angle, right? Draw an arrow going across. What leg, or what is that now? Is that still the
That's the
adjacent leg?
opposite.
Now it's the opposite leg. What's the 55 now? That's the adjacent leg. What's the 73? The hypotenuse. So it stays the same. Sine.
So you never do a right angle ever?
No.
We have to use all these errors.
So the sine. Sine is what two parts? The so part.
Opposite leg over hypotenuse.
Opposite over hypotenuse. What's the opposite this time?
48 over 73.
48 over 73. So that goes in the sine blank. The slower you do it, I think the worse you make it sometimes. The cosine. Cosine, the c part, A and H, what's that?
55 over 73.
Adjacent over hypotenuse, so 55 over 73. And the tangent.
48 over 55.
48 over 55, opposite over adjacent. Anybody notice anything about the tangent of angle A and the tangent of angle B?
They're just flip-flop.
They're flipped over. Anybody notice anything about the sine and cosine of angle A and the sine and cosine of angle B? They switched around. Next slide. This time they only gave us two of them. How can we find that third side, the hypotenuse?
By using Pythagorean theorem.
Gives you a hint right there, doesn't it? So a squared plus b squared equals c squared. What's a this time? 36. What's b?
77.
What's c?
Question.
X. We don't know. That's what we're trying to find, right? So you got 36 squared plus 77 squared equals c squared. Type into your calculator 36 squared plus 77 squared.
7,225.
Anybody else get that?
Yes.
Now, is that our answer?
Then I divide it.
You do what to it? You take the
Square root.
square root, right? So what's the square root of 7,225?
85.
85. So how long is segment AB over there?
85.
So write 85 in there for us, Mike. Now we pick an angle. We're gonna start with angle A again, I guess.
Yeah.
So put the little arc in angle A, draw your arrow going across. So that 77 is the what?
Opposite.
Opposite leg. What's the 36?
Adjacent.
Adjacent leg. What's the 85?
Hypotenuse.
Hypotenuse. Label the triangle every time. What's the sine of angle A?
77 over 85.
77 over 85, everybody agree with Joseph? What's the cosine of angle A? Cosine, the
36
co part, adjacent over hypotenuse.
36 over 85.
36 over 85. And
77 over 36.
77 over 36 for tangent, everybody agree with that?
Yeah.
Let's do the same thing real quick for angle B. What's gonna change when you get to angle B?
The opposite and the adjacent.
The opposite and the adjacent change spots, right? So now the 77 is the adjacent leg, the 36 is the opposite leg. So what's the sine gonna be?
36 over 85.
36 over 85, what's the cosine gonna be?
77 over 85.
77 over 85, what's the tangent gonna be?
36 over 77.
36 over 77.
Slow.
Will it always
Huh?
look like this?
Well, what?
Never mind, I figured it out.
So, do we know what angle A is? No. Do we know what angle B is? No, we don't care. Not right at this moment, at least. All right? All we're doing is setting up these ratios. And we're going to end up setting up both sides of the equation here in a few minutes, but we're taking it one step at a time. All right? Next slide. Next slide. That's just showing you how to do all this. Next slide. What's the missing side there? We're not going to do this one, but what's that missing side, AC? If it's one of the triples. What is it? 5. Does everybody remember that?
Yeah.
5, 12, 13. If it's that triple, we could do the sine, cosine, tangent. Next slide. Same thing. Next slide. Tricks you, doesn't it? And it stays. It goes down here, then up here, then down here. Look at this chart real quick. Look down the sine column, both sine columns. Look down through there. What do you notice about the number?
1, 2, 3, 4.
No, the sign. Look under the sign.
It's 0, 1.
Just look at all of them. Give me something about everything in the sine column. First of all, how many places does everyone go out? 4. So it goes out 4. You can grab another one if you want to have it up there with you. So it goes out 4 places. That's normally what we want to do when we're doing sine, cosine, tangent. Go out 4 places behind the decimal. Does anybody notice anything else about them?
The
What-
tens column is going in order from 0, 1.
All the way up
0
to
to 9.
0 to 9. Does it ever get higher?
Nope.
No.
So we know sine is always less than how much?
9. 10.
Not 10. Look at where the decimal. 1 whole, right?
9.
Sine always has to be a decimal number. It can't be 1 point anything or 2 point anything. Look at the cosine ones.
They're below 1.
They're all less than 1 also, aren't they? Sine and cosine can never be more than 1. So if you come up with the sine that's 3.5, you screwed up. You probably divided wrong in your calculator. All right? Now look at the tangent. Is it the same way?
No.
No, tangent goes
The 57.
all the way up to whatever, and tangent can be any number. All right? Next slide. If you know the angle, so if you know the angle measure and you want to find the trig ratio, you can either use the chart. That's what Fletcher wants to use because he wants to prove that he's smarter than Ebersole was at this age,
I
right?
thought it was easier because you can go all the way down and
Yep. So if I wanted to use the chart and I wanted the cosine of 15 degrees, somebody tell me what's the cosine of 15 degrees?
0.9659.
It's not too hard, all right? I made it sound like I was some genius or something. That's not the case, all right? But I did use this all the time instead of using the calculator. Now grab your calculator, and on your calculator, hit cosine 15, and what's it say?
0.9659258263.
Same thing, just more numbers, right?
Yeah.
We want to go out 4 places, so it's the same thing. If we want to, if you know the angle measure, So if you know the angle's 15 degrees and you want to find the trig ratio, you can either use the chart or the calculator. This is the steps you're going to use. You're going to hit sine on your calculator, put in the angle measure, hit equals. All right? So on the front page of the packet, go ahead and go to the next slide. It should be the front page of the packet. Oh no, it's a calculator, sorry. There it is. Here. I'm gonna give you a calculator while we're doing this, so that you can punch it in at the same thing that we're doing. We're gonna do this. First thing I want you to do though, down on number 11 and number 13, can everybody find those?
Yep.
Yeah.
Mark out 80 degrees. Those are supposed to be 30 degrees. 11 and 13, both 30 degrees. So mark out 80 on both of them, put 30 in there. All right? All we're going to do is we're going to punch these in. So grab your calculator. What are you going to punch in on the first one?
Cosine 30.
Cosine 65. So hit cosine 65.
26.
What's it come up to be?
0.4226.
And look, Ebersole's calculator says negative 0.562453. Is that what everybody else got?
Wait, what did you say you got, Fletcher?
Point this.
Okay, yeah.
So-
I thought you said two something.
So what that tells me
26.
is my calculator's messed up and I need to go in here and fix it. If your calculator ever tells you something like that everybody else isn't, then we need to know so I can turn it back to the right thing.
What mode would it be in? Still classic?
Yeah, yours should probably still be in classic.
Okay.
Let's see, I gotta find this. Sorry. I
I
gotta
kinda like
find-
the chart because I know I didn't type it in wrong.
You can use the chart to check if nothing else, just to have both of them.
And you have to use a calculator to, like, number 367.4.
Right, it's, some of them aren't on the chart. Number,
Would we still round or just?
mode, there it is, take on. Yes, you're gonna go out 4 places,
Okay.
every single time, 4 decimal places.
When I try to do number 9, which is 1090, it says error.
Really?
Yeah. It's the only one that said error.
Oh yeah, that's what mine says. Donated.
When it actually,
On 1090?
Yeah.
Really?
Yep.
I thought you were not supposed to like choose 90.
Oh, we're not supposed to pick the 90-degree angle, are we?
No.
Oh, so that's probably why it says that.
12 and
So mark that one out.
12 and 14 are both 90s.
Try them though.
But those are cosines and
If it's sine and cosine of 90, now let's think about it. Why won't the tan of 90 work? Tangent is opposite over adjacent. If we look at the right angle,
Or just
which side's opposite the right angle?
hypotenuse.
The hypotenuse. Which one's adjacent to the right angle?
I have a question.
They're both hooked to the right angle, aren't they?
Yeah.
That's why it won't do it.
The center.
Because it doesn't know which one to do. Alright?
Number 12 just comes out
On
to
number
1.
3,
That's
I
right.
did it and it says 2.4023. Would we still
That's
just do
also
the
big.
4 decimals?
Yep.
So 2 point then the 4.
Yep. And I'm guessing since you're saying that's 2 point something, it's gotta be a tangent.
Yeah.
Yeah.
Because if it was a sine or cosine, something's wrong.
Alright.
Because only tangents can be bigger than,
Can I go through and do one, I'm already on number 4, can I just do it one?
yep.
I've already been doing them all. We're not supposed to.
Nope, go right ahead. Guys think you'd handle it, or do we need to do them together?
I think it's
I can
fine.
do
This one just says 1.
Allie, you're not saying anything, we
It'd be
need to do them
90.
together?
It's a
You can handle it?
It's the 40.
So write 'em in there.
number 5.
Yeah, it's supposed to be 1.
Help me out here, Maya, so I can fill in yours. Cosine 65. You might want to come back here, because it's probably gonna be annoying to some of these people if you're hollering numbers out there trying to write stuff down. Even though I really don't care if it's annoying to them or not. You just wanna write them? Yeah, it's up to you. Go on, Taylor. You don't want to use my pencils. Thanks.
For the tangents, would we write the number and then the decimal?
No, you're right. So like, the one you guys said a little while ago, 2 point something something?
Yeah.
You just write 2 point,
Okay.
and then 4 places behind the decimal.
Alright.
You getting them all, Joey? They easy? Ally, you get them all? Gwen, how you coming? You alright? No questions? Ally, you wouldn't lie to me, would you? Look like you're confused. So you can just fill all those in on your own?
That's maybe the first thing we did, I think we'll understand.
So just fill them all in. Again, you're gonna turn this in at the end of class, so. You lost one decimal. You were having trouble writing that fourth number down there, I thought. So we'll grab a different one. I wondered why you were sitting there lying to me and not writing.
Trying to, if not.
I just figured you like being a liar, and not telling. Let me see that one real quick, just the random, just to make sure somebody hasn't changed it. No, it's all right.
Oh, shoot,
Yeah, go ahead. Zero, really? One of them came out zero?
Yeah, 14.
I got 12 as one too.
Yeah.
One's all right, zero's just.
Do you want the recording paused?
It was a
Yeah,
90-degree
There
cosine.
was another 90 one.
Yeah, cosine.
So, would the other sign of 90 come out?
One.
One. So one of them didn't work, one of them came out zero, and one of them came out one with 90.
Yeah, so
For
on number
14.
9, I just put no.
You got one?
Yeah, that's the other one.
No, you said
12
14,
and
you got
5,
zero.
I got 1.
For cosine for 90, I got
Zero.
I think I got 0, yeah.
He said sign of 90 got one.
Oh, yeah, I thought he said the cosine. I got one.
That was. On the other side, is it just we have to figure out what that is, what that belongs to?
We're getting ready to do it here in about 10 seconds. Giving Maya a chance to get herself caught up. But she's doing all my work for her. Sorry, Maya, you don't get any much yet.
Oh, these have X numbers down
I think you missed this one. I think that's supposed to be a 2. Yeah, 2.1542. Are you kidding me? You really think I have all these memorized that I would know that?
I really don't know, I can lie.
Are you kidding? I'm glad that you have that high thought of me. You think I could memorize all this stuff?
Where'd you put it?
How far are you, Ally?
Yeah, I'm good.
Go ahead, go to the next slide. It's just gonna be the same page.
I don't think he saw me do it either.
Go ahead and go to the next
There's a
one.
whole lot of-
Find this on your notes. Give Ally another second or so. If you can figure out what it says up there, read the directions, that's just the steps to do it. And it's gonna be the second page of your packet. Out to the side here, do me a favor. Out to the side, write sine, S-I-N. And like you're putting an exponent on the end, put -1, a little -1.
Okay, I may be kind of.
Now, everybody look at this. You see what she just wrote up there?
Yeah.
What this is doing, when it says sine, cosine, or tangent, -1 as the exponent, it's like telling the calculator to do the reverse. So instead of finding the sine, now what we're going to do is use the sine. We're going to know the sine, and we're going to use that to find the angle measure. For the angle measures, in this class, it might be different anywhere else, but in this class, if you're looking for an angle, round it off to the nearest whole number, nearest degree. So if it comes out on your calculator 52.3, round it off to 52 degrees. All right?
Okay, that was easy.
So all we're going to do on these, on that second page, you push the second button. Can everybody find the second button on their calculator?
Yep.
You got to push it first. Now, Gentry, on the other calculator, you would have to push. What you do is you put in the number first, then hit the second, then the sign. So the first two are switched around. All right? So you hit the second button, then you put in the decimal or the ratio, whether it's a fraction or a decimal, you put that in, then you hit equals, and it tells you the angle measure. So on the front page, we knew the angles, and we were finding the decimal answer. Now what we're doing is we know the decimal answer,
We're finding the whole.
and we're finding the angle, what the actual angle is. All right? So let's do the first one. Go ahead and go to the next slide.
29.
Yeah.
Next slide. So this one, on my calculator, I hit second, sine, and I put in that number, 0.4848. And then I hit equals.
For the tan, where we did put the second.
I just used the chart and went backwards.
You could use the chart and go backwards too. But the bad thing is not all of them will fall on the chart. So you'd have to sort of,
Joseph, what did you say that you did for?
oh, yeah, on yours,
Write it down.
yours, instead of hitting the second button, you see how yours has sine and sine -1? So you do this. You push sine, push it again, and it goes, that's like the second button.
Okay, so for the tan, how did we?
Do the same thing.
So hit the second, do all of.
Second, so everybody got 29 on the first one, right?
Yeah.
29 degrees, that's your answer. 29 degrees.
I was doing it, yeah.
Which one you guys on, 25? So on 25, we hit second, tan, 2.05,
But when I checked 64.
03.
Oh, because I was looking in the wrong spot.
It's easier to do the chart if I.
and it's 64 degrees.
Yeah. Okay,
You
thank you.
just go
Joseph.
straight backwards.
Well, I just did like I was looking in the wrong section on my sheet and back checking. That's what.
So what everybody get? Oops, I put it in the wrong spot. Sorry, Maya messed up your picture.
Oh, yeah, can you hear me?
For 25, I got 64 degrees.
So 25, 64 degrees, everybody agree with that?
Yep.
Does that make sense? Does everybody know how to do those?
Yes.
So try to do, you can do like down to 33, then when you get to 34, if you're having trouble still with 34, stop and we'll do some of those together. What do you think on 34 through the rest of them? What do you have to do before you do all that stuff on your calculator?
Change it to a decimal.
Change it to a decimal, because that's what your calculator understands.
So that'd be 0.5.
So on that first one, it's just 0.5, yeah.
What is cosine W and cosine A?
That's, so A is your angle, or W is your angle. That big letter's saying the sine of angle A is that number that they're giving you.
On these, I think it's easier to use the
How are we supposed to put in
sheet.
36? I'm confused on that one.
So first thing you do, change it to a decimal first. So on your calculator, or Sam, on your calculator, you can do this. Because I know which calculator you have. Do second cosine, all right? And then just type in what that is. You see how it's got the parenthesis on your calculator already?
Yeah, square root.
So then do second square root divided, square root of, what is that, 2? Go ahead, Jeremy.
Yeah,
Divided by 2, then close the parenthesis. Actually, you'll have to close the parenthesis twice. And then hit equals.
So I put a parentheses around the square root of 2 and the entire equation as well.
Yeah, I messed mine up.
Yeah, that's.
Hold on a second.
So you do parentheses.
So it might be easier to do this, Sam. Do second square root 2 equals divided by 2 equals, and get the number. What number is it?
Wait, you said.
So just take the square root of 2 divided by 2.
Square root of 2 divided by 2. It says error on that one. But I didn't put parentheses or anything.
You didn't need any parentheses.
Yeah, it says. So if I did, because I put it as my good. So square root of.
Do the square root of 2, hit equals, then divide that answer by 2.
Divided by 2.
Okay? Now, that answer's right there on your calculator.
Yeah.
Okay? So now hit second, what was it, cosine?
Yeah.
Cosine, and type in that number. And you only really have to go out 4 places.
Okay.
Figure it out?
Yeah, 45 degrees is what I got. For 36.
Okay.
Yep. Is everybody about down to 34?
Yeah.
Can I have you check this?
Sam, what did you do for 36?
So for 36, I did the square root of 2, and I pressed
I'm hoping you got it right, because I'm.
And then I divided that by 2, and then got that big long decimal answer. And then I just hit second, cosine, and then type that number again. Since
You
it's
got
all-
52 on that.
But I only went 4 decimals out.
33, 54, 87, 47, 65, 28. So,
Did you get 45?
Yeah.
which one was it? 27. So 20.
Is this one? Oh,
27.
mine's different than yours, but
Oh, it's
once you have the
27.
parentheses,
Here, grab my calculator.
I
So,
add in.
second
close
cosine.
parentheses.
Do we round to get the decimal? Because mine says 54.73.
Yeah, just nearest degree. Nearest whole number.
51. Yeah, she's definitely.
So what is it?
It's 52.
52 degrees?
Yep.
Now, on the rest of them, and Maya's already figured it out over here on hers, but on like the second one, or on 34, instead of putting in 0.5,
I got 55.
if you hit
38.
second, sine, and then just put in 1 divided by 2 and close the parentheses, if you put in the fraction, it'll do it that way. You don't have to worry about doing the division.
Did you do tangents?
Should our answers be negatives?
Nope.
Okay, let me just do 38 again.
You get a negative answer on something.
Even for 41 and 42?
So for 38,
Hey,
it's.
Maya, did you do 30 on, or 34?
Tangent.
Oh, that's
Or,
nice.
you don't even
Did
do
you-
that.
You divide it by 3 though instead of.
Yeah, but-
Oh, so 41 and 42, they are a little different, aren't they?
Yeah, I got negative for that too.
Okay.
41 I got negatives, and then
Yeah.
the 42 I got 129.
0.5773. And I got 29. Okay, that, I don't know why that gave me it.
Yeah,
No.
30.
Let's see.
Yeah, I don't know what I did.
See, because when you do it that way, it doesn't understand the parentheses. So what you have to do on that, see, if I'm gonna put it in the way you're putting it in, hit second.
Give me 1 second.
Which one is it? Cosine, and we want
36, did you get 0?
square root of 2, second square root 2, we want to close the parenthesis right there. And then divided by 2, then another parenthesis to close the first one. And then hit equals. That's what it should be. So that's why sometimes it might be better to just change that to a decimal and then punch in the decimal. Because some, you know, especially if you don't know. Because I know that right there is the cosine of a 45-degree angle. So that makes it easy for me, but for you, you don't.
Well, it didn't show the negative on those ones, and like it did on those ones for the roots.
I don't know, are 44, 45, and 43 different? Or we just use those as negatives?
Cause they don't have the negative after the thing, it's just zero.
No, they're the same thing. They're just like they were up top. That symbol, if you're looking down at the bottom, 43, 44, and 45,
Yeah.
that symbol looks like a O with a little tilde through it. That's called an omega. And I'm just showing you that. Will you do me a favor and switch the board, Sam? So if you look at that symbol, that omega symbol, 99.9% of the time, if you're looking at an angle, circle that one of those omega symbols down there for me. If you're looking for an angle, the symbol that they use to stand for an angle is that omega symbol. So that's why I put those on there.
With the negative one, will the angle come out as negative? Okay. I was just making sure that.
Does anybody have any idea what that means when the angle comes out negative?
That it's.
So if I'm here and my angle normally goes like this, what do you think that angle does?
It's gonna be that.
Goes the other way.
Question, for 42,
Joe Swab.
should it be 120
What?
30, 60.
I got 129
40,
degrees
did you get
for 42.
Okay.
Did you get negative 47 for, number 41?
Yeah, negative 37.
41.
Yeah, no, 40.
So have you guys done your,
30, or, sorry, 40?
Yeah, 31.
Yeah.
Points,
Well,
it's like 30.7.
yeah, that's what we're
Yeah,
doing.
You really didn't seem very hungry except for like
You put me downstairs.
48 for the hour.
Honestly.
Downstairs is all about detail, while upstairs is gone. I got a two-key perspective. I'll do that with you.
That symbol,
Where's that?
that's what most
42,
geometry
did you
classes
get,
and stuff
129?
use to represent any angle.
For what is it?
So it just says sine of some angle, so just like this up here, it says cosine of angle A, that means the same thing, it's just another way.
I'm
So
43,
when
I
you're
got
out in the real world,
33.
to stand for an angle,
How? What did you do?
that omega symbol, that usually means
Or
angle.
43
So
and
do I
then
have to press the second one?
Yeah,
I
it's
took,
same, you're doing
I did
the
the same thing
exact
that I
same
did up
thing.
here, I took the square root of 2, hit enter. Right.
43?
So 42, you didn't get a negative answer, right?
43, I took,
No.
second said, point 0.5, and I hit enter, and I
Oh,
didn't.
I didn't do the second, I just did it. That's
I
all.
just did the regular sign.
Figure that.
No, I don't.
Did you get 30 for 43, Joe?
Yep.
Wait,
You just said
I just
you have
hope
to
I'm not doing
you
this
have to
one.
go to the hair book.
So is everybody understanding this stuff so far?
Yeah.
Now, you ready, Ally, to go to something where we're actually using it and not just punching numbers into the calculator?
No, I'm not enjoying this, I actually understand it, give me a minute to get used to.
So we should stop for a minute and just let Fletcher enjoy his knowledge.
Yeah, well, I still got it.
For 1 minute.
Honestly,
I know I'm jumping ahead, but for question 49, when I went to find the angle, I did 65 squared plus 33 squared, got 5,314, and then I divided that by 2, and it's still like, it's still a pretty big number, is that okay?
It could still be a big number, but if you're doing that,
I'm using the diagram theorem.
right, you're finding the side,
Yeah.
you're not finding the angle, so you're finding the side of the triangle. They want you to find the
Joseph.
angle.
Well, do I have to find the side to find the angle?
No, not necessarily.
I did it right.
I think you set up Pythagorean theorem wrong, because which one of those is your hypotenuse?
65.
So you gotta do 65, what'd you say you did?
I did 65 squared plus 33
You'd
squared.
have to minus the 33 squared,
Um,
and then take the square root of that.
I started something weird.
Oh my goodness, you're jumping ahead.
I don't know.
Oh my God.
Let's see if I can do it. Anyways, I think I did it right.
We'll find out here in a minute.
Don't make me wait. Come on now.
We're not, we're going on right now.
I
What
got
would be
two
the
left.
next step to
That's all I need.
49, because if you do the minus, it's 31, 36.
This almost makes me feel good, Fletcher. I might go home tonight and I'd say I gotta shut up.
Then what would you
Because
do?
I'm-
Well, I understand it.
I know, it makes me feel good that you guys are actually, you're thinking ahead and now you want. Go ahead, next slide. Next
My
slide.
math capabilities are not the greatest.
What would the next step be for 49?
All right, on your notes, real quick, back to your notes. Fill this in real quick, we gotta hurry. So first thing you're gonna do, pick an angle. Second thing you're gonna do, label the triangle. Maya, can I use like the triangle symbol instead of writing out triangle? And you're gonna label it opposite, adjacent, hypotenuse, every time. Third thing, you're gonna write an equation. In that equation, this is what we're gonna do next, and this is what you guys are starting to do on those other two problems. In that equation, this is what you're gonna do every time. You're gonna find the trig name. What I mean by trig name, sine, cosine, or tangent, all right? Then the angle that you pick. So you're gonna write down the trig name, you're gonna write down the angle that you pick, then the hardest part of all of it, you're gonna write down an equal sign. Make sure you don't mess that up, Joseph. Then you're gonna write the ratio. And I know that doesn't make a whole lot of sense yet, but it will here in a minute. Everybody got that much? Go to the next slide.
Pardon me, teachers, for the interruption. Any music student that has butter braids to pick
To
up
find an
riding the bus,
angle
please come down at this time.
of
and
a
pick that up.
triangle.
Thank you.
To find an angle of a triangle, you're going to do these steps. Pick the angle, label the triangle, decide whether you're using sine, cosine, or tangent, write out your equation, push second, then sine, cosine, or tangent, whichever one you use, put in the decimal or the fraction, hit enter. It's going to give you your answer, and you're going to round off the answer, just like the problems we were just doing. All right? Look at problem 49. Problem 49. First thing, we got to pick an angle. That's what it says do first. Which angle are we going to pick? The one that's X. So put a little arc in X where that angle X there is. Then we're going to label the triangle. The side across from X, that's the 33. Draw your little arrow across through there. What's that get labeled in?
Opposite.
Opposite. The side down on the bottom, segment MB, what's it get labeled? Adjacent. Side across from the right angle, what's it get labeled? Hypotenuse. Each time you're doing one of these problems, all the time, two of the sides are going to matter, one of them is not going to matter. So you guys were using Pythagorean's theorem to find that bottom side? No reason to. We don't need it. All right? Look at the two sides that we do know. 33 and 65. One of them's the opposite, the other one is the hypotenuse. Which trig ratio uses opposite and hypotenuse? The so part, so sine. So that's what you're going to write down first. Sine, S-I-N. What's our angle?
65.
X. So sine X, then the hard part, equals, and then on the other side, you're going to actually make the fraction bar and put in the fraction. Sine, the so part, is opposite over hypotenuse, right? So what's the opposite? 33 over 65. Does everybody see what Maya has on the board up there? That's exactly what you should have.
And that's the answer.
That's not the answer, because we want X. Now, you're gonna do exactly what we were just doing on that other page. You take your calculator,
0088.
you could divide it first, but I'm gonna tell you this. Easier way, hit second, sign, and then just put the fraction right in there. 33 divided by what?
65.
65. Close the parenthesis.
Oh, there's parentheses.
And what's it tell you?
30.5.
30.5. So about how many degrees?
31.
31 degrees. That's your answer.
Oh, okay.
Wow, that was super easy. Can we go back to 48?
Yep,
We
48.
2 minutes left. So.
On 48, first go back to the notes. Go next slide. To find the side of a triangle, you're doing the exact same thing. On 48, go ahead and go to the next slide. On 48, I'm going to explain how to do this. First of all, you got to pick an angle. Which angle do you think we're going to deal with here?
H.
40.
No.
You're right, H. The 40-degree angle, right? So put the arc in the 40-degree angle. And then you're going to label the triangle. What's the X get labeled? Opposite. What's the 21 get labeled? Adjacent. What's the side across from the right angle get labeled? Hypotenuse. Which side do we really not care about this time? The hypotenuse. So we care about opposite and adjacent. Which trig ratio deals with that? So write down tan. What's our angle?
40.
40. Again, the hardest part next. Equals what over what?
X over 21.
X over 21. Now, this is where it's a little different. Go ahead and punch in your calculator, tangent of 40. What's it tell you?
0.8391.
Write that number down, 0.8391. Yeah, it rounds up to 1. So right below tangent, 0.8391. Now, the next thing I'm going to do, let me borrow this real quick. Probably shop me, so I won't do it. We know that that equals x over 21. To make it easy on you, this is what I want you to do next. Put a 1 underneath that. So, got this over 1 equals x over 21.
Oh, and then you do.
Now, what is it? It's a
Cross multiply.
proportion. You just cross multiply and solve.
So,
18.
What did it come out to be? 18. Let's go out at least one place. When we're finding a side,
I didn't get 18.
you didn't get 18?
I got 18.
17.6211.
Yeah.
Oh, so if we're finding a side, my fault. If we're finding an angle, round it off to the nearest whole number. If we're finding a side, let's go out to the tenths place.
17.6.
17.6. Everybody agree with that?
Yep.
So how long is that hypotenuse in that triangle?
76.
Or I'm sorry, that's not the hypotenuse. It's x. Ah, crap. I wrote all your answers on the wrong one. Hang on to that. The thing I do want you to do, though, there's a packet right over there on that table. That's your homework.
Ebersole, nothing.
Rebecca Dunbar,
I'll send out.
could you please come to the middle school office?
Remind me
Rebecca
next
Dunbar,
time
come
that
to
we
the middle
didn't
school
finish this
office.
very last part of the notes, all right? Mine, you don't remember all that, or do you? Here. My key. It's not finished, but it's got those other three packet problems on it, shows you how to do them. That'll help you with the homework. That way everybody has something to look at. I was going to,
I don't know how I ended up getting any of that, because honestly, that was probably harder than anything else.
it's definitely harder. Maybe you just haven't been trying very hard on the other stuff.
Oh my god, I have to grab my charger and my phone.
Because all those times I look back at you and I say, Fletcher is doing this or something just to get your attention.
Ebersole, I slept for 11 and a half hours last night. I don't know how the world is.
Because you're off into space.
Did Sam?
Shoot, I do that when I'm driving my car.
Oh my God.
Have a good night. Oh. About broke my wrist. I guess I should push stop up or shouldn't I?
You want me to get it?
It doesn't matter, I don't know if I'll save this one or not. Should I save this one? Just push the middle button. There you go. So again, on this one, when you get this, you cross multiply here, and you just end up with 1x. So that's easy. Sometimes you'll have to divide, this time you don't have to. And I think you guys told me when you did it on your calculator, it's 17.6. So that tells us that this side of that triangle right there is 17.6. Ignore all those stray marks. The last thing here, fill this in, just on word problems, and we're going to go back over some of this next class also. On some of the word problems, they'll use these two expressions, angle of elevation and angle of depression. Angle of elevation, if I'm looking, if this is my eye, and I start off looking straight out, and then I turn my eyesight going up, that's an angle of elevation. That angle right there is an angle of elevation. You're always starting with your eye level going straight out. So if it's an angle of depression, if this is my eye, and I'm looking straight out, an angle of depression looks down that way. That's an angle of depression. Nothing really hard about it. It's just on some of these problems you got to draw pictures. So you'll want to stick that in there. Again, the homework is the other packet, not the packet that we did together in class, but the other packet.